right, here's number 4. The biggest pain in the butt with these problems is putting all the data into your table. But yada, 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 there's all this unnecessary information, big old chart. But then it says compute the correlation between the number of 2007 wins, so this column, with the cost per wins, with this column. This is going to be X and Y. And we're going to put this data into L1 and this data into L2. So I already did that just to save some time. So here is my data. Just when you do it, double check it to make sure it's right. If you have one number wrong, it's going to throw everything off. Okay, so what's the correlation? The correlation we're going to find is R, which is sometimes called the correlation coefficient. Okay, so there's 2 ways you can do that. Looking at the other problems you wanted to go over, I think the second way I'll show you is better because it just gives you everything, but I'll show you both ways. So you can do it, you can find that by using just a regular linear regression. But if you do a regular linear regression, it's just going to give you a printout of the equation. It's not going to give you R squared. So before you do that, what you want to do is you want to go to hit second and go to the catalog, second 0. And then you're going to scroll all the way down to the D section where it says diagnostic on. If you're going to use the second method I show you, you don't have to do this at all. This is just if you want to use the first method. Go to diagnostic on, hit enter again. It says done, good. So now I'm going to go to stat. My information's in my list, so I'm going to go to calculate. I'm looking for the linear regression, okay? Or the line of best fit, that's option 4. So I'm going to have my X values come from L1, my Y values come from L2, and I'm going to hit calculate. And usually this R squared and R wouldn't be here, but since we turn the diagnostic on, that pops up. Okay, so we don't need the top 2 pieces of information. It just says compute the correlation between the number of wins and cost per win. That's R. So R here is going to be negative 0.2773. Or I'm sorry, negative 2.277 to the nearest 1,000. Okay, so that's your answer for the first guy. Give me 1 second. All right, that's what you need for that. So if you want to use the second one, I'll show you. It actually gives you more information, which you'll need for other problems. But that requires us to go to stat, then over to the test menu. I'm going to scroll up until I get to the LinReg t-test. It's just going to give you some more information involving the t-test statistic. So I'm going to click F. Everything's really the same, except the only new thing is this beta and rho. So you're just going to make sure that says not equal to 0. That's never really going to change. And we'll hit calculate there. You're going to get a lot more stuff, okay? You probably saw in another question it asked for the t statistic and the p-value. That's right there at the top. But if you scroll down, our R is at the bottom. Notice it's the same thing, negative 0.2773. Okay, so for the other examples, I'm just going to stick with this to show you, because you're going to need this because it asks for more information than just the R value. So that's all you have to do. So all this other stuff is just not necessary. All right, number 10, same thing. I'm going to pause the video and put the data in my calculator. Just give me 1 second. You'll actually see instantaneous for you. Okay, and we're back. So I put the data into L1, the X value is in L1, the Y value is in L2. Usually with these problems, you can tell what the outlier is. I don't really know if you can tell by looking at this what it's supposed to be. Maybe this first one, because 4.5 seems a little low. But so what we're going to do now, it says make a scatter plot. So once you have the data input there, I'm going to go to the stat plot menu, which is right here. So hit second, Y equals. I want to go to my first plot. It says off. I'm going to turn that on. So I'm going to hit enter on that. Make sure it's turned on. I want a scatter plot. That's the first option there. My X values are from L1. My Y values are from L2. And you can pick what you want it to look like. Doesn't matter. Color is blue. Okay, that's all good and great. So now what I'm going to do is I want to make sure my graph fits all those plots, all those points. So I'm going to hit zoom right in the middle at the top. Zoom. And I'm going to do zoom stat. That'll make sure my graph fits perfectly. Okay, so looking at this data, we see that there's all these points, and then there's one way out here. Okay, so let's see what that point is. I can hit trace. And it looks like that point is, in fact, the 77.2, 4.5. So this point is our outlier. As soon as you graph it, you should be able to tell which point's the outlier. It's just one really, really far out. But if you can't tell by looking at the graph, you hit trace, and you can just hit left and right. Hit trace again. Okay, yep, that's what I want. No, I want to zoom 9. Hit trace. You should be able to jump. There we go, left and right. So there we go. Now I can jump through. Like that, left and right. You go zoom, so you can highlight it until that one pops up, and it's 77.2 and 4.5. So we have, make sure you write it as an ordered pair, 77.2, 4.5. Find the regression equation for the data set without the outlier. So what we're going to do is go back to our stat menu, edit our list. I'm taking that point out. So if I just want to delete one value, I'm going to hit select that value and hit delete. So it's 77.2, delete. Okay, so I have the data without the outlier. So then I can either use the linear regression t-test, or I can just use the linear regression function. So I'll just use that. My x values are L1, my y values are L2. I'm going to calculate. It gives me this printout. So it says, as an equation in slope-intercept form with parameters rounded to 3 decimal places. So we have y equals ax plus b. This is my a. This is my b. So it's going to be, I'm going to write it over here, y equals a, which is negative 1.433 times x, plus my b, which is 115.060, or plus 115.060. We don't have to write that. So there's my regression equation without the outlier. Okay, so that's this guy. Now it says find the data set, the equation with the outlier. I guess we could have done that one first. Doesn't matter. Now we have to add this point back in. So I'm going to go back to the stat menu, edit my list. And you don't have to add it to the top. It just doesn't matter where it goes. So I'm trying to add it back to the bottom. 77.2 and 4.5. And then do it all again. Stat, calculate linear regression. Boom, 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 calculate. And let's see if it changes. Now my equation is negative 1.43, 1.431, no, 1.432. Okay. So this is y equals negative 1.432 x plus 115.023. Okay, that's that equation. Now, is the outlier an influential point? Did the outlier have a big effect on our equations? Are these equations very different? I mean, these are basically the same number. These are basically the same number. So the outlier, with or without it, doesn't really change anything. The outlier does not seem to be an influential point. Okay?